Okay, so if you assume true for n equals k, that means that when n equals k, that means that 2 times 2 plus 3 times 2 squared plus n plus k plus 1 times 2 to the k equals k 2 to the k plus 1. Okay, so now what you have to do is prove true for n equals k plus 1. So when you're doing n equals k plus 1, what you're required to prove is that 2 times 2 plus 3 times 2 to the 2 plus k plus 1 times 2 to the k plus k plus 2, because you've got to add one more on, times 2 to the k plus 1 equals k plus 1, because instead of a k I'm putting k plus 1, 2 to the k plus 1 plus 1, which is k plus 2. Okay, so in order to prove that, if I go to the left hand side, the 2 times 2 to the k plus 3 times 2 squared plus k plus 1 times 2 to the k, that represents s to the k, and the k plus 2 times 2 to the k plus 1, that represents the kth term, k plus 1. And what we're trying to do is trying to make all of that equal k plus 1, 2 to the k plus 2. So if we take this, that is all the way up to, down to there I mean, if you take that part there, it's 2 to the k plus 2, 2 to the k plus 1. When you take that part there, that represents the sum to k. Now by assumption, the sum to k is equal to k to the 2k plus 1, because if you look up here, that's what that's actually equal to. Then plus k plus 2 times 2 to the k plus 1. Okay, so if you look at that, there is a common factor of 2 to the k plus 1 is the common factor, because if you look at that, you've got 2 to the k plus 1, 2 to the k plus 1. So when you take that out, you'll have k plus 2 left. Remember our prize, keep your eye on your prize, that's what we're trying to get to. K plus 1, 2 to the k plus 2. Okay, so we've got 2 to the k plus 1 times, now that's going to be 2k plus 2. So how am I going to make it look like that? Now, you could go two ways. You can try and get this, or you could try and get the other one. But if you take out the 2, then you have 2k plus 1. And then if you look at that, you can add the indices. So you've got 2 to the k plus 1 plus 2 to the 1. When you add the indices, that is 2 to the k plus 2 times k plus 1, which is what we're trying to get here. So therefore it equals the right-hand side, and we're done, we're proven. So I think the key here is once you've got it set up, you've got to be able to take out the common factors and then add the other part, and it's recognising that there is a factor of 2 in here, and that 2 can be pulled out as 2 to the 1, and it can go with the other 2, because you can just add the indices because it'll be the same base.